Okay, in this video, I'm going to show you how to solve equations, quadratic equations by factoring. Okay, the first example I'm going to do for you is very, very simple. Is to give, is factor already equal to 0. Now, the first thing you do is assume that this is 0. So 0 times all of this will give you 0. So what's under 0 should be equal to 0. So that is x plus 3. That quantity should be equal to 0. Now, what is 0 is over here. All of this times 0 will give you 0. So it's underneath here should be equal to 0. So that is x plus 1 is equal to 0. Now, solve for x. That'll be -3, -3. And these two values are opposite, so they're going to cancel. So we have x is equal to 0 minus 3 will be -3. Now the other problem is get the x by itself. The opposite of plus 1 will be -1, -1. Now because these are opposites, they're going to cancel. So we have x is equal to -1, and that is the answer. Now the next example is not factored, okay? So I have to factor it before I can do the work. Now when you solve quadratics, they should be equal to 0. So I need this equal to 0. You can put the 0 wherever you want. In this case, the easiest side will be this because you only have to get rid of one number. So the opposite of -88n will be positive 88n. And what you do to one side, do it to the other, plus 88n. Now, these are opposites, they're gonna cancel. So if they cancel, there's nothing left over. Nothing is 0. And write this in descending order from the highest power to the lowest power. The highest power is 8n squared. The next lowest power will be plus 88n plus 240. Now, first thing is see if they have anything in common. It looks to me that they have a number in common. This will be factors of 8 will be 2 times 2 times 2 times n times n. Factors of 88 will be 8 times 11, which is 8 is 2 times 2 times 2 times 11 times n. 240 is a big number, so I'm going to do the following. 240 factors. Let's say we use 24 and 10. Factors of 24 will be 3 and 8. Factors of 10 will be 2 and 5. This is prime. This is prime. This is prime. Factors of 8 will be 2 times 2, and those are prime. So instead of writing 240, I'm going to write the factors in order. That would be 2 times 2 times 2 times 3 times 5, and that will be equal to 0. Okay. Now, what factors do they have in common? So what does this and this, what factors do they have in common? So looking at this, they have 2 2's and they have 3 of them in common. So they have 2 times 2 times 2 in common, and 2 times 2 times 2 will give you 8, and that's all they have in common. Now, leftovers. If I take this out, what you have left over is the n squared. n times n plus, take out what they have in common, that'll be 11n plus, take out what they have in common, well, take out the twos, and you have 15 left over, equal to 0. Now for this, I need to use it is a quadratic, and there's this trinomial, 3 of them, so I can use the x box method. So here's my x, and here is my box. Now, the value put in here is multiply the first times the last, that'll be 15 n square. What you put in here is the middle one, 11n, and this will be n square, and this will be 15. Mm, you know what? I have a feeling I mess up right here. Let's do it again. Factorial 240. I said it was 24 and 10. Factors of 24 will be 3 and 8. Factors of 10 will be 2 and 5. These are prime. Factors of 8 will be 2 and 2. And those are prime. So there should be 3 2s, 3 and 5. That's right. It's okay. Mm -hmm. Hmm. Hmm. Let me check on this. Okay, I found the mistake already. It should be in 2 times 2 times 2 times 2 times 3 times 5. So what happens here, I'm missing a 2. Now, this is going to be 15. This should have been 30. Okay, so this should have been plus 30. Now, if that's the case, this shouldn't be 15. This should have been 30. 30 n squared. So in this case, this should be 30 n squared. Now, factors of 30, take this and put over here and give me the factors in order. So we have 30 n squared, and the factors will be 1n and 30n. 2 will be 2n and 15n. 3 will be 3n and 10n. 4 will be, nope, 5 will be 5n and 6n. 6 will be 6n and 5n, but they're repeating already. So you're done. Now, which of these can I combine to give me 11n? This will give me 11n. Sorry, that should have been 11n. So the combination that I was looking for, 5n and 6n. So the numbers that I'm missing here is 5n, 6n, 5n, and 6n. So this should have been 5n, and this should have been 6n. Same over here, 5n and 6n. Now, what do these two have in common? They have an n in common. What do these two have in common? Factor they have in common is a 5, and these two will be an n, and this two will be a 3. Okay, squared. I don't worry about this. Okay, the mistake is right here. This is no longer 15. That should be 30. So what these two have in common is a 5. What these two have in common is a 6. This should be a 6. So the problem, this becomes 8 times equal to 0. The first factor is n plus 5. Second factor is n plus 6. Now set each of the factors equal to 0. 8 should be equal to 0. This n plus 5 should also be equal to 0. And the third factor must be equal to 0. There's no way that 8 can be equal to 0. That cannot be an answer. Now set this equal to 0 minus 5 from both sides. They're opposite, so they cancel. So you have n is equal to negative 5. Set this equal to 0. That means negative 6 from both sides. These are opposite, so they cancel. So you have n is equal to negative 6. And that is the answer. Okay. So this is why you learn factoring, so you can solve quadratics. Okay. In real life, the government, the military, or formal companies are gonna pay you $1 million to factor this. Okay. They're gonna pay you the big money to solve a quadratic. Okay. And that's why you need factoring, because one of the ways we solve quadratics is by factoring. Okay. Thank you.